Hi, hello, who are you? My name is Anna Tenpensa. Welcome back to my channel. I'm going through as many LeetCode problems as I physically possibly can in a year, and you guys are here for question number 96, unique binary search trees. This is the third binary search tree question they have given me today, and obviously I did not have to do these all in one day, but here we are. I am ready to tackle this. The last question I did, which was 95, was a lot better than the other ones that I've done today. So without much further ado, let us jump in to question number 96, unique binary search trees. Now, let's read through this question together once or twice, but my brain is already in binary search tree mode, so I'm going to have to read through it too many times. So given an integer n, return the number of structurally unique binary search trees which have exactly n nodes of unique values from 1 to n. How is this not literally so similar? Hold on, you guys, look at this. Oh, wait. This is the... Gotcha. Okay. Yeah, okay. I got it. I understand. Now I'm looking at the examples. Input is 3, output is 5. 1, 2, 3, 4, 5. Got it. I just was thinking this was... I need to read through... Again, why we read through the problems more than once. So given an integer n, return the number of structurally unique binary search trees, which has exactly n nodes of unique values from 1 to n. Now the constraints on this one, the last time I think it was 8. This one is 19. And then these examples here make sense. But because it's just a number, we can just use some DP. Listen, dynamic programming. That's it for me. Delicious. So let's go ahead. Let's jump right in here and start with the base case. So if n is equal to 0, then we just return 0. Easy. It's cut and dry. It cuts out if the input is n. Or if the input n is 0, then there's nothing there. Simple. Now, let's initialize an array to store all of this. Specifically, when I say all of this, I mean the number of unique binary search trees. So let's say dp is plus n plus 1. Okay, so there is one unique binary search tree for empty trees and one unique binary search tree for one node. So we can start by saying dp 0 and dp1 is equal to 1 and 1. I love this question. Now we can use dynamic programming to fill in that array. Let's go. So we're going to say for I in range, we're going to say 2n plus 1. Then we're going to say for j in range of I, we're going to have dp I, which, hold on. I'm getting ahead of myself. I'm sorry. I'm not explaining what I'm doing. So allow me to break this down. So when we say for each value I, we're going to iterate through values j from 0 to I minus 1 and basically take the number of unique binary search trees using the following formula, which is dpi, here, let me write this, dpi plus equal dp j times dp, I think I'm going to do I minus j minus 1. So that's how we iterate through those values over this. So we accumulate those numbers of unique paths that way. So all then we have to do after this is just return the DPN. But I just want to make sure that we all understand what is going on here. So we have our base case, which if you were to plug that in, actually let's do that here. Let's say if n equals 0 when we run it. So that will return this case. Then we initialize the array to store those number of unique paths that we have available for the given BTS. Then we break that down to saying if there is if there's an empty tree, then there's still technically one unique path, but also if there's at least one node, then there's one unique path. That way we're kind of controlling possible errors with select edge cases if we have them. And then we take this DP to fill in the DP array, and I kind of explained that already. Then we just return DPN. But we have to say return, otherwise we just have DPN. Okay, so I feel pretty good about that, actually, in terms of a solution. Let's go ahead and run it with this extra case. If you guys are doing this yourself, feel free to run this with that 0, just so you guys can see what I'm talking about for this. I guess it doesn't. Yeah, okay, never mind. Invalid test case. Oh, that's right, from one. I guess it doesn't matter. Just kidding. It doesn't really matter. Okay, so we have here, I did a plus, this should be a multiply, wrong equation. Okay, good, excellent. So I think that's it. Okay, let's go ahead. I haven't submitted anything for this yet, so you guys can see I haven't submitted anything. Let's go ahead and submit this. Ooh, that's what I'm talking about. Beating 91% of users with Python in memory. I'm beating 59% of users in Python in runtime. What a great day. What a great day. We are getting better. I just needed a couple question warm up, and here we are. We're doing a aight. So I will leave this code in the GitHub repo, linked down in the video description down below. Please feel free to fork and clone, make it better, make it worse, have some fun, learn something new, and I will see you all in the next video. Thank you so much for watching. Goodbye.